How's it going, guys? This is Mahalis. I'm one of your TAs for DS3000, and today marks the first tutorial video for one of your math topics. Today I'll be doing vector operations, so we'll get started. Please bear with my handwriting, especially on this Mac system. Still getting used to the pen on this app, but yeah, let's get started and we'll go from there. So let me just write out some things. So we're dealing with vector and I'll abbreviate it. We're dealing with vector operations. Cool. So, what are vector operations? It's when we take two vectors or maybe more vectors and manipulate them, kind of like what we do in a basic algebra class, like doing one plus one, but now we're manipulating entire data structures worth, right? So, let's define an example. We're going to start off with addition just to start. Okay, please bear with me with these. All right, so let's say we have an example here. We're going to define a vector A equals, so A is 5, 1. B is set equal to, let's say B equal to -3 and then 3. Yeah, sorry about the handwriting. If you want, please feel free to skip through the video to get to the actual operation part. I'm going to be doing this out as I go, so yep, please bear with me. And yeah, let's add the two together. So when adding matrices, or vectors in this case, we're going to take the two vectors, and this is good to, where I'm just going to show all the work that's required to get full credit. So we're going to add the two together. So that's taking this symbol plus this symbol, so A plus B. We're going to set that equal to 5, 1, and then add that to -3, 3. And basically, how this works is we're going to split it by column essentially. So make sure when you're doing vector addition that the dimensions of the vector match. I think I said matrices, but yeah, I'm talking about vectors here. Make sure that the dimensions match. So if this was a 1 by or a 3 by 1, it wouldn't work with this 2 by 1, right? Because you're missing one number here that could have been applied somewhere here, right? So in this case, we have a 2 by 1 plus a 2 by 1, and each row in this case has a respective partner, let's say. So from here, we're just going to set up a final matrix or final vector. We're going to do 5 minus 3, that is 2, and then 1 plus 3, which is just 4. So this is your final answer. We're going to box this soon, and there we go for addition. Okay, so we're back here again. So let's go about doing vector subtraction, right? Very similar process. I'm going to abbreviate here. So let's just say sub dot dot underline. So yeah, same thing, same process as the addition. So we're going to take vector A minus vector B. We're going to set that equal to the vectors themselves. So 5, 1, close that, minus 3, 3. And then our final answer, well, dimensions match again. Each row has a respective attribute. So we're going to do 5 minus 3, which turns into 5 plus 3, which is just 8. And the bottom row is 1 minus 3, which is just -2. So that is your final answer, and that's all we need for subtraction. Okay, we're back again. So today, or for this section at least, we're going to be talking about scalar multiplication. So what is scalar multiplication, right? So I'm sure you guys have gone over in class when we're multiplying matrices or vectors together, right? You have to look for dimensions matching, etc., right? But in this case, we're dealing with a scalar, right? So with scalars, there's a little bit of a different process. Still multiplying this about the same way, but rather than going about the same tedious process as you might with like a 3 by 3 times a 3 by 3, it's much simpler. So the way we go about it, so let's say you need to solve for 2a, right? Oftentimes you'll just get a problem written like this on, like, let's say an exam. So you have a defined vector, let's say 5, 1 from the previous examples, and we're just given this little operation, or this little expression, right? So the way we'll go about it is we'll set this equal to 2 times. We're going to write out the vector here. So 2 times 5 and 1. So what do we do here? This scalar is just a number, right? And when we have a basic number being multiplied across a vector, all we're doing is multiplying each component within the vector by this number. So that would look like, and this is an optional portion to your work. This isn't really necessary, but you can write out something like this. Again, bear with my handwriting here on the tablet, but here we go. Okay, so as you can see, we're multiplying 2 by 5 and then 2 by 1. This will then result in, again, 2 times 5 here and then 2 times 1. This will then result in 10 in the first section and then 2 in the bottom section. So this is pretty much it for scalar multiplication. On exams, you might get longer problems, but it's just the same process. So 2 times, let's say 5, 1, 0, 3. You're multiplying that 2 by every single component and then writing out the answer in a very similar structure to this, right? And another question that comes up a lot in exams is what do you deal with when you get like let's say a matrix, bring it down to a scalar and then multiply it against another, let's say vector or other system, right? So that is something I will cover in the matrix multiplication section because it's more relevant there. It makes sense to just multiply 2 here by 5 and 1 in this vector, but just to be clear about what I'm talking about, sometimes you'll get an operation that results in an answer like this, and then you need to multiply it by, let's say, 5 and 1 again. So when this happens, a 1 by 1 matrix in this case, it's the same thing as just a scalar, right? It's just the number here, right? So you can remove these walls if you want them, the little matrix operator, whatever you want to call them, brackets, right? And then proceed to multiply them by 5 and 1, just like we did, and get 10 2 as an answer. Let me know if you guys have questions on this, and we'll go over some of these more in detail. All right, welcome back. Please bear with my handwriting again, still getting used to this. But for another vector operation that we're going to be dealing with is the L2 norm. So this is just one of the norms that you'll talk about along your machine learning journey. There's stuff like L0 norms, L1, L2, L infinity norms, and so on. There are lots of norms out there, just depending on what you pass in for a subscript into X. But don't worry about that until you get to machine learning. If that's the path you go down, for now, we're going to be dealing with L2 norm for now. So the L2 norm of a vector in simple terms is just the length of a vector. So sometimes on exams, or at least what I had last year, my professor would say, find the length of a vector A, right? And that was all it was given, right? But that immediately it signified to me to use a certain formula. And that certain formula was part of this same expression, the L2 norm of vector. Again, means the same thing as the length of a vector. I will just write that down over here. So the formula to use is we're going to take the vector x, take the absolute value of this vector, and also take its, or this is magnitude actually. So we're going to take its magnitude. So set that equal to radical over the summation starting at I of x squared, and then I is at the bottom here. So basically, we're going to square every single element within the vector here. So let's say we get a 5 by 1, right? We're going to take each component, 5 times 5 squared plus 1 squared, because we're doing a summation here, and then we're going to square root everything. So that's all there is to this. Again, this is very similar to just a basic magnitude problem. But let's go move on. So I'm going to write out an example here. So let's say A is equal to, let's try a little harder problems now. So 2 minus 1 and 4. That's 2 minus 1, 4. And we have B is equal to, let's do -3, 3, -3. Yeah, sorry about the spacing, but yeah, this is a negative, negative up here. So -3, 3, -3. All right, so oftentimes, again, once again, for these kinds of problems, you'll usually just get some kind of expression. So on my exams, for example, I'd get something like this. So A minus B, and then we're going to put that inside of a magnitude expression. So how do we go about this, right? My recommendation is, well, first analyze the question, right? Think about how many parts you have and how you should really divvy it up to get to the final answer a little bit quicker and much more easily, right? So right off the bat, I can see two operations, right? There's vector subtraction here, which is what we did earlier in this video. And then we also have to take the magnitude, which is what we learned here. So let's start off. You don't have to number it, but I will number it just for the sake of understanding how this works. So we're going to start with a subtraction first. So A minus B, essentially just moving in and out. So 2 minus 1, 4. And then we're going to add or subtract it from negative 3, 3, negative 3. Cool. So from here, what we're going to do is do 2 minus negative 3, which is just 5. Watch the signage, right? Next, we'll do negative 1 minus 3, which is negative 4. Sorry about the handwriting once again. And then 4 minus 3, which is just 7. So 5, negative 4, 7. And yeah, that's your answer for A minus B. So that is our vector. And now we do the second part. So let's number it like so. So A minus B. Dun, dun. All right, cool. So this part is very simple in my opinion. So basically, this problem appears in many math classes, especially Calc 2, for example, Calc 2 and Calc 3. But basically, we're going to take each component within here and square them. So 5 squared. Oh my Lord, I'm going to erase that. Looks very bad. Okay, there we go. 5 squared plus. And make sure to watch the signage here. Any negatives will become positives and being squared. Remember that. And then plus 7 squared. I'm just going to skip a little bit of work here. Please write it out on the exam, but just for the sake of less writing on my end, we're going to have 25 plus 16 plus 49, which gets us 90. And oftentimes you'll be asked to just find the decimal. I'm not going to use a calculator in this case. I'll just round it to a simple number. So 90 can be split up, and that can be rounded down to 3 root 10. But again, on an exam, you're more likely to be asked to convert this number, this radical, into a decimal. So yeah, just keep that in mind, but this is all there is to the vector norm. There's not really any tricks to it that Mohit might throw at you. But yeah, here's a good example, and ask me any questions if you have them. Okay, welcome back. Today we're going to be dealing with the Hadamard product. So Hadamard product is very similar to basic multiplication, dot product, it's so on, except it has a distinct process to it. Again, you're still multiplying, but the answer that you're going to get is going to be set up differently than how you would for a dot product. Dot product will come out after this video, but yeah, we'll focus on Hadamard for now, so I'll just write it out for you. So Hadamard product. So again, product just signifies it's another multiplication system. But yeah, no need to fret. This system is actually pretty easy. So this is an H, so Hadamard product. Again, bear with my handwriting, please. But yeah, let's jump into an example. So let's set A equal to 5, 1. So these are just going to be the same vectors from the beginning of this video. And then B is equal to negative 3, 3, I believe was the vector. So all right, let's get to it. So the Hadamard product is set up very similar to the other expressions we worked with, except it has this little blank circle. When you see this blank circle, I want you guys to quickly go, oh, that's Hadamard, okay? Dot product would just be a dot like so. I can draw it out a little more. So dot like that. But in this case, we're just dealing with a big O with nothing in the middle except this little black outline. So that's what we're dealing with. So let's operate. So I want you guys to write out the vectors to show us some work, how you got to your answer. 5, 1, and then negative 3, 3. So how do we get to this answer? I said it was similar to dot product, and yes, you are multiplying, but you're not adding any values together per se. What we're doing here is divvying it up by row, and again, make sure the dimensions match. In this case, we have pairs for every row. So we're chilling in this case. So what we're going to do is split up, like let's say evenly along this horizontal line. We're going to do 5 times negative 3 and then 1 times 3. And what does that get you? All right. Actually, I'll skip this step. It's very similar to one of the multiplication steps before. But again, 5 times negative 3 will get us to negative 15. And then 1 times 3 is 3. So that's all we're doing with Hadamard. We're just taking it by row. So let's do something like that and multiplying this by this, and then this by that. So 1 by 3 and then 5 by negative 3. Those will be split up separately like so. So negative 15 and 3. This will be your final answer. And there you go. That's all there is to the Hadamard product. Expect questions like set up like this on exam, for example. But that's it. We're back, and this should be the final section to this video, and it's probably the most important one. And we're dealing with the dot product today. So let me just write it out for you. So dot product is probably the most important operation you will be working with in your machine learning slash data science careers. I mean, it comes up very often when we're dealing with Python. So you'll be having to manipulate this a lot, especially in classes like machine learning 1 and 2. Let me get a quick drink of water here. Thanks. All right, so dot product is simply just multiplying things or the components of each vector, so 5 by negative 3 and 1 by 3, and then adding the two together. Obviously, these problems can get very big very quickly, so keep an eye on what you're multiplying and watch the signages, right? So just a quick note, dot product is set up in several ways. So how we typically write it out is we'll do a this little dot B. And this is fine, right? If you're given a vectors, and when we say matching dimensions, right, usually you would assume you need the inner dimensions to match, right? That is true with vector. With in this case with dot product, it still applies, but there is some leniency when it comes to just saying A times B, because we automatically know you're trying to go row by row here. So very similar to Hadamard, you're just going to split it up by row and then add the two together instead. But tr other examples might do something like this. So you'll say the vector A transpose B. So what is this saying, right? So this would be written as, so we take the transpose of 5 and 1, right? So something like 5, 1, and multiply it by negative 3, 3. From here, we can apply that very basic dimension rule. So this is a 1 by 2. We're multiplying it by a 2 by 1. The inner dimensions are 2, and they match for both. So our resulting matrix will be a 1, 1 matrix. In this case, just a scalar, right? So we'll do 5 times negative 3 times 1 times 3. And in this case, this will be, so 5 by negative 3 plus, and then we have 1 by 3. And this is equal to, so we have negative 15 and 3, which is equal to negative 12. Okay, that's it. Again, I'll do it out the other way. Remember, you'll probably be getting an expression like, say, A times B. Again, this is what you're probably going to be getting, not just a couple of vectors lined up together like this. But this, in this case, would be the expression, like I said earlier, A transpose B. Remember, transpose, you're just taking a vector like 5 and 1 and then swapping its row order. So rather than going 5, 1 by column, you're going to go 5, 1 by row, like this, for example. So this would just be A transpose T. Oh yeah, and with dot product, you don't have to write out this dot. If there is a dot like this, that signifies, again, dot product, but sometimes it'll just be written like this, which also signifies dot product without any dot present here. So that's what we have here, and we're setting this equal to that. So, but going back to the other example, we're doing A times B. This is 5, 1. Again, it's a very similar process to the stuff up top, so I'm not going to elaborate too much on it. So 5, 1 times negative 3, 3. And again, it's the same answers. We're just doing 5 by negative 3. It's like this. So this line of work is being carried down here, and we're setting this equal to negative 12. So either of these work as an answer. Again, it just depends on how this is set up. But either way, with dot product, it's a little more lenient when it comes to how you're multiplying things. So this expression up here is as valid as this one up here. It's just preference of the professor and how the exam is written. But yeah, negative 12 is your answer. And I believe that concludes the video. But if you guys have any questions, please let me know and I'll help you guys out. And yeah, good luck.